Hey guys, welcome to the video number 9 of the entire cryptography series. In this one, we are going to talk about some concept related to quantum key distribution. In my previous video also, I have spoken about that quantum cryptography is kind of because, cryptography is one side, but quantum computing itself is generating a lot of threat when it comes to, cryptography, because the computing power has grown so much, and that can be a threat. And normal cryptography, which is kind of secure today, can be insecure by using quantum computing. Now, in that sense, what if we start using quantum computing itself for the entire key distribution? Can that be possible, right? And definitely that is one of the concept of the entire big quantum cryptography. One of the key aspect is quantum key distribution. So in this video, we are going to talk about the same. Let's get into this and try to understand, what principle this particular quantum key distribution is based on. And it is very, very interesting, So what is the principle on which the entire thing is based? The entire thing is based on quantum mechanics. Okay, we use quantum mechanics to make sure that the particular communication is traveling from point A to point B in the shape of photons. Photons means light, right? And if somebody is trying to play around with that particular light, we are able to measure it as well at the same time. And because we are able to measure it, you are able to detect if a particular photon has been, somebody has tried to play around with that. A very good thing is the photons which are carrying actually the data, right? They can neither be copied like other data packets and all. Photons cannot be copied, and they can only be measured only once. So that generates a big challenge for anybody who is trying to break these kind of keys. So let's try to understand how this entire thing works, how it works. Let's say this is Mr. A, and Mr. A wants to send a particular key. Like in the entire communication, we are talking about key distribution. We are not talking about the message distribution. The main thing is how we set up the key. So in this one, let's say Mr. A wants to set up a secure communication with B, and for that they need to exchange the keys. So what will happen is, as you know, in quantum cryptography, the message will be converted into light particles called as photons, and that will be traveling on the entire channel. Now this particular channel can be a free space, okay, based on line of sight and things like it, or it can also be fiber optics. Now what will happen is, all these photons, or we are calling it as particles, normally a particular photon is oscillating. It is actually oscillating, going from point A to point B, then coming to point C, and it keep on doing this. It is traveling in a wavelength kind of thing. Okay, it is actually traveling in a wavelength kind of thing, and there is no fixed direction of a particular photon when it is traveling from point A to point B. So what will happen is, when Mr. A want to send a particular message to Mr. B, what they will do, they will use a phenomena. They don't want that random movement of this particular photon. What they will do, they will set up this particular photon in a particular direction. Let's say this direction, or we set up in this direction, or we set up in this direction. Like all these different directions are there. Thus the mechanism of setting up the direction of a particular photon is called as polarization. And when we want to do this particular communication between the two parties, either we are going to polarize a particular quantum particle as vertical, or we will tag it as horizontal, two different states. And when A sends a particular message to B, there is a pre-decided order. Okay, we have to receive these photons only. Okay, in a particular setting they are going to send across. They will send across this data with other photons as well. Like for example, in this entire thing there will be lot many other photons also which will be traveling. Now what will happen is, only those photons which are set to go will only be passing through this particular thing. Rest all will, you know, they will they will come back, they will get reflected back. Only the required photons who have the authority to get inside will get inside. Similarly, if on the other end Mr. B has made an arrangement for a horizontal photon, this horizontal photon will then go away. Rest all here and there will be kind of you can say they will be ignored. And this way, out of this entire thing, let's say there are certain photons which came in from here. Like you have sent some photons, let's say this, then you send one vertical, then you send some other form, and then you send some horizontal. On the other side, they will be able to measure all this. If they do not match, let's say they are not matching, okay, let's say they are not matching, or let's say this is horizontal, right? Then the rest of them which is not matching can be ignored, and once they are kind of ignored, that means they are not valid. So they will not be treated as a key thing. Only those photons which are matching will be taken as a key. So this is a very secure way to actually transmit the key in a real time situation. If a particular hacker is trying to come here in between and he is trying to get this data hold, one thing is, all these particles, they can only be measured only once. Second thing is, you cannot even store it like other data packets. So this makes very difficult for a particular attacker to break it, and that is why this particular quantum key exchange is going to be the normal norms in the time to come. There is a lot of research happening on this, and there are some groundbreaking you can say development in this particular area. So in the very near future, you can expect that we start using quantum key exchanges. One of the challenges, quantum key exchange is very good when you are using it for a long distances. That is where it works perfectly. Sometimes for short distance it doesn't work that great. So these are some of the limitations and advantages of the quantum key distribution, right? So that was the key concept from a CISSP perspective, and as you guys are heading into cryptography, this is one of the things which you have to come across in the very near future, so you should know it.